Herbal drugs must be of high quality, effective and safe. The quality of the pharmaceutical product must be integrated into the production process. This means that all phases of the development and production of a drug are carried out with risk assessment and mitigation. All processes, from planning, seed selection, cultivation, harvesting and drying of plants and their processing, must be carefully planned and traceable. We must ensure both the safety aspect of the finished product and the safety of production workers. In the cultivation of plants, we follow the guidelines of good agricultural and harvesting practices for medicinal plants and the principles of good manufacturing practices prescribed in Europe by the European Medicines Agency in processing. We ensure the traceability of materials and processes through documentation that is part of every production. In Europe, we prepare a certificate of active substances, excipients and other substances according to the European Pharmacopoeia. The results of quality control tests are recorded on that certificate, which is a document that contains the following information in the case of herbal drugs: the Slovenian and Latin name of the herbal drug, its origin and source, the year of harvest, the expiration date and information regarding which guidelines were followed in the preparation. The certificate must also include the results of prescribed tests, such as the content of active substances, impurities, water, total ash, heavy metals and pesticides, microbiological tests and others. However, we must first identify the herbal drug that is the subject of this exercise. The identification of an herbal drug is carried out in different ways. Organoleptic means by observing the properties of an herbal drug that are visible to the naked eye or under a microscope, and the properties that we can smell or taste. Using chromatographic methods, we separate and identify compounds characteristic of an herbal drug. In this exercise, chemical identification will be carried out in order to observe the change in color caused by active substances in an herbal drug under the influence of added reagents. The first chemical test will confirm the identity of herbal drug yarrow, which is called Millefoli herba in Latin. The European Medicines Agency states in monograph of yarrow herb that is used to treat loss of appetite, mild abdominal problems such as cramps, bloating and flatulence, mild menstrual cramps and minor superficial wounds. The main active substances responsible for the action of yarrow herb are volatile terpenes and terpenoids, that is, the components of essential oil, flavonoids and sesquiterpene lactones. Instructions for conducting the test can be found in the European Pharmacopoeia. We carefully read the monograph, record the necessary reagents and look for instructions for their preparation in other chapters of the Pharmacopoeia. The monograph provides the following instructions. To 2 grams of the powdered herbal drug, add 25 milliliters of ethyl acetate. Shake for 5 minutes and filter. Evaporate to dryness in a water bath and dissolve the residue in 0.5 milliliters of toluene. To 0.1 milliliter of this solution, add 2.5 milliliter of dimethylaminobenzaldehyde solution and heat in a water bath for 2 minutes. Allow to cool. Add 5 milliliters of light petroleum and shake the mixture vigorously. The aqueous layer shows blue or greenish-blue color. As we can see, we need 2 grams of powdered herbal drugs and 4 reagents for this test. They are identified by their R code. Learn how each of them is prepared in the Pharmacopoeia under the heading Reagents. Ethyl acetate in the reagent section directs us to the ethyl acetate monograph. It is described as a clear colorless liquid. We cannot prepare such a substance ourselves, but must buy it from a chemical supplier. We require ethyl acetate of pharmacopoeial quality, which guarantees that the chemical purchased has listed properties. In order to avoid the risk of misidentification of the chemical, we may provide a supplier with a unique CAS, number of the American Chemical Society, at the time of the inquiry or order. Like ethyl acetate, toluene and petroleum ether have their own monographs. Take care to purchase so-called light petroleum ether, which consists of petroleum fraction with molecules with boiling point of between 40 and 70 degrees Celsius. The reference to the third reagent, however, leads us to the instruction for this preparation, which states: dissolve 0.25 grams of dimethylaminobenzaldehyde in a mixture of 5 grams of phosphoric acid, 45 grams of water and 50 grams of anhydrous acetic acid. Prepare immediately before use. In the reagent section, we find dimethylamino-benzaldehyde, phosphoric acid, water, and anhydrous acetic acid, which directs us to their monographs. This gives us information about the specifications of the chemicals that we provide to the supplier. First, we weigh 45 grams of water, then 5 grams of phosphoric acid, and then 50 grams of acetic acid. Because of the exothermic reaction, we never add water to acid, but always acid to water, for safety reasons. Since the acids are very volatile and irritating, we must work wearing a hood, weigh 0.25 grams of dimethylamino-benzaldehyde, and slowly add an acidic solution while stirring in droplets. When we have all the reagents and accessories ready, we perform the main reaction. To 2 grams of the powdered herbal drug, add 25 milliliters of ethyl acetate. Shake for 5 minutes and filter. Evaporate to dryness in a water bath and dissolve the residue in 0.5 milliliters of toluene. To 0.1 milliliter of this solution, add 2.5 milliliter of dimethylamino-benzaldehyde solution and heat in a water bath for 2 minutes. Allow to cool. Add 5 milliliters of light petroleum and shake the mixture vigorously. The aqueous layer shows a blue or greenish-blue color. The water layer turns blue to greenish-blue as evidenced by the presence of sesquiterpene lactones, more specifically proazolene. Achillicin, achillin, artapsin, and guanolide are found, for example, in yarrow. As a second example, we will use oak bark. The bark of oak trees is used according to the monograph of the European Medicines Agency for the treatment of mild diarrhea, mild inflammation of the skin and oral mucosa, and itching and burning pain in hemorrhoids. A chemical test will determine the identity of the herbal drug by demonstrating its active ingredients, which will change color in reaction with prescribed reagents. How do we test oak bark? The instructions state: to 1 gram of powdered herbal drug, add 10 milliliters of 30% ethanol and heat the mixture under a reflux condenser in a water bath for 30 minutes. Cool and filter. To 1 milliliter of this solution, add 2 milliliter of 10 grams per liter solution of vanillin in hydrochloric acid. A red color develops. Ethanol is prepared with the help of alcoholimetric tables found in the pharmacopoeia. Due to volume concentration, the mixture cannot be prepared by dosing volumes. Since the boiling point of ethanol is 70 degrees Celsius, we heat under reflux to avoid the loss of solvent due to evaporation. The procedure is suitable for active substances soluble in ethanol. Ethanol also has a greater ability to dissolve structures in cell walls to soften the herbal drug and release the active substances from the solid structure of the bark. When vanillin in hydrochloric acid is added to the solution, it turns intense red. The red color produced by the reaction with this reagent is characteristic of tannins. These are substances due to which oak bark has an astringent action. The general effects of tannins are used to relieve inflammation of the oral cavity, against diarrhea, and in hemorrhoids. On the skin, we achieve an anti-inflammatory and anti-hydrotic effect, anti-sweating, with the help of tannins. Tannins are also used for tanning leather, a process in which proteins coagulate. In the latter case, we will perform an identification test for Iceland moss. Iceland moss is a thallus, that is, a symbiotic organism between a fungus and an alga. It is a gray-brown drug. We need a solution of iodine. According to the instructions, it is prepared from 0.05 molar iodine. and 0.6 gram of potassium iodide. Iodine is prepared from 12.7 grams of iodine and 20 grams of potassium iodide. Why make two solutions from the same reagents? We work gradually because potassium iodide in the appropriate ratio with iodine helps to dissolve it. The chemical test for the presence of polysaccharides in Iceland moss is carried out by first pouring 5 ml of water over 1 gram of the sprayed drug. In this case, we do not heat in a water bath, but directly on the heater since the water must boil. We get a grayish solution that solidifies when cooled. Why? Icelandic lichen contains water-soluble polysaccharides that consist of 70% licanin. It forms a protective and moisturizing layer on our mucous membranes, while lichen acids have an anti-inflammatory effect. The water-soluble form of iodine is I3, which is trapped in the helix of licanin, namely the amylose molecule. A Alkyl triiodide ion complex is formed. The length of the iodide bond is prolonged and the solution becomes blue.